Okay, now so energies or energy basically. Energy is the ability to do work, right? Or well, as we know, all energy cannot be created or destroyed. It can only be transferred from one form to another. It's measured in joules, okay? Energy is a scalar quantity. So if we look at energies that's all around us, we got two types. We've got the potentials, the potentials basic, which energies that can be stored, and then we're gonna talk about the transferables. So I'm gonna go through each one of these. So gravitational potential energy is one of the energies you have to calculate. So for example, let's say that this height, the box was raised the height of 10 centimeters. Okay, and the box had a mass of, let's say, 1,000 grams. And he's asking you to calculate the gain in gravitational potential energy. So that would be mgh. Keep in mind the mass have to be in kilograms, so that is 1. And the height have to be must be converted into meters, so that is 0.1 times, let's say the gravity is 10, so that is 1 to 0.1 times 10, that is 1 times 1, so this would be the box gaining 1.0 joules of energy. Always mind those two significant figures, okay? So gravitational energy is the energy gained due to the elevation or the gain in height of an object. Now, elastic potential energy, energy stored in any object is being stretched, bent, or twisted, basically. It is a type of energy that is stored, okay? So moving on, you've got chemical potential energy. Is the energy it's stored inside of batteries, petrols, or food. We as humans, we use the food, petrol for the cars, also batteries in cars and other devices, okay? And also there is the nuclear potential energy. One is the nuclear fusion, nuclear fission. We're not gonna go through these a lot in this lesson. It's mostly in nuclear, but you need to know what is nuclear potential energy. Okay, so all of these are energies that can be stored, and then you can use them some other time. They can be stored for a long time. Okay. Now we gonna talk about the transferable energy. The first one that you're gonna have to calculate is the kinetic energy. Now kinetic energy is equal to the half multiplied by mass multiplied by the velocity squared. So if you have an object with a mass of 200 grams and is moving at a velocity of, let's say, 5 meters per second, you want to calculate its kinetic energy. So kinetic energy is going to be equal to half multiplied by the mass. The mass has to be converted, divided by 1,000, so that is 0.2 times 5. Don't forget the square. Most of the times you guys forget the squaring. So that would be, so that's 25 times 0.1, so that would give you 2.5 joules. Okay, that's the basically how to calculate kinetic energy. So it's the energy that is of an object that is moving, right? Then you've got thermal energy. It's the most abundant type of energy. Everything that you do produces thermal energy. Any activity mostly is going to be producing thermal energy. And then you've got the idea of sound energy, and it's the energy of sound that we all know. Then there's the light energy, energy produced by the electrons vibrating, electromagnetic, and so on, causing the light energy. And then the electrical energy, which is the energy created from generators that is stored in the magnetic potential energy. We don't really have the magnetic potential energy, but you should know it. You should know that inside of magnets, there is something called magnetic potential energy, where we could get the electrical energy from. And then this is the internal energy. You need to know the definition. What is it? It's the sum of potential and kinetic energy of particles. So whenever you're defining internal energy, it considers the potentials and the sum of the potential energy and the kinetic energy of the particles. All of what I just said is under one big umbrella of law that energy cannot be created or destroyed. It can be only transferred from one form to another. So this is one of the examples. You've got this guy, he's going up and then he's gonna go down. So this guy, before he went on his picnic or whatever the sport is doing, he ate some food, so that's chemical energy. And then that chemical energy is being transferred to, as you can see now, it's kinetic and is also gaining what? Gravitational potential energy until he reaches the top. Now he stops. Now at this point, he's got maximum potential energy and minimum kinetic energy. As he moves down, now he's got more of the kinetic energy, and the potential energy is decreasing until he reaches the endpoint. Now at the endpoint, some of the energy, of course, is going to be transferred to thermal energy, and some losses to other things like sound and heat, right? Same thing for this pendulum. As it swings, it transforms from the maximum to maximum potential energy to both to minimum potential energy with maximum kinetic energy, and so on. Okay, now let's move to the idea of calculations. Now, if you have an object that is basically being dropped or being thrown with a certain velocity, you can calculate a lot of things knowing just simple givens, right? So, for example, you've got this diver. It's gonna jump. She's gonna drop into the pool, and you're asked to calculate the final velocity with only the height is given. So you should follow this idea: energy before is equal to energy after, given that there is no energy wasted, you know. So they can tell you air resistance is ignored, there's no work done against resistive forces. That is one of the most important things to apply this law. Okay? So having that she had the gravitational potential energy, it's going to be kinetic energy. We can apply those two laws. The masses cancel out, right? And then you multiply by 2. So you got T 2GH V squared. Then make V subject by square rooting both sides. So you get that V at the end is going to be equal to root 2GH, which translates to 14 meter per second. So when this lady jumped and she's about to fall into the pool, she had a velocity of 14 meter per second. This can be done in an inverse way. What if I gave you the velocity and I'm asking the height it's gonna reach? So therefore make H subject from that law. So if you make H subject from here, you just divide by 2G and 2G. So you get H is equal to V squared over 2G. Okay, so applying that law, you're gonna get H is equal to 14 squared divided by 2G. You're gonna find that H is also equal to 10 meters. So basically goes both ways. Also, the last thing they could also ask you for, they could give you the rest and ask for the gravity. See, if you want to get gravity given height and velocity, so gravity is going to be equal to V squared over 2H, and this is a question that actually came in the past papers. Okay, thank you for listening.